Hello everybody, I will summarize today another coding practice. So in this video, I solved the question candy. And this is not my first time to solve this question in this YouTube channel. I actually solved this question a month ago and posted a video, but I decided to solve this question because the practicing something repetitively is quite important. Yeah. Okay, so that being said, let me get started. So in this question, there are n children standing in a line. Each child is assigned a rating value given in the integer array ratings. You were given candies. You were giving candies to these children subjected to the following requirement. Each child must have at least one candy. Okay. And children with the higher rating get more candies than their neighbors. Return the minimum number of candies. You need to have to distribute the candies to the children. Minimum number of candies I need to have to distribute the candies to children. Okay. So let me clarify the question statement first. So in this question, I'm given the the array of integers, and n is not given actually as the input. So this is the ratings list, which is an array of integers, and this represents the rating for each child. And my task is to distribute candies. I mean, according to the rating for each child. And then as the output, I will return the integer, which is the minimum number of candies I need to have. To distribute candies to children. Okay. And the requirement is that okay, so one thing I'd like to confirm about the input is that firstly, if the ratings array can be empty or not. And I check it in the constraint and find that it's not empty. Okay. And one more thing I'd like to confirm is that's basically it. Okay, good. Okay, so I will take a look at the requirement again. So each child must have at least one candy. Okay. And children with higher rating get more candies than the neighbors. So I guess this is probably because it's a child with higher ratings get less candy than the child which is standing next to him. And if that person gets more candy, it's not quite fair for that child. I think that's the reason why this requirement exists. Okay. And it doesn't say if, there are two children, adjacent children. If the ratings of them are the same, like 2 and 2, in that case, it is okay that I distribute the candy, the first child. Distribute 3 candies to the first child with the rating 2, and then I distribute, say, 5 candies to the second child, which has the same rating 3. So that's a kind of a tricky thing I have to take care. Okay, so with that being said, let me think of this question with some examples. For example like this, in this case, I don't know how many candies I should give, but say 1. Oh, so let me start with 4. Okay, so in this case, I don't know how many candies to give here, but because I have this child which is smaller, so he has to get 1 and then 2. And then I will take a look at this, and I find that this child is higher than 3, so this get 2 or something. And for this, he can get um, I don't know how many candies, but at least from the left child, there's no constraint for this person. So maybe one, because I'd like to minimize the number of candies to distribute. But when I take a look at the right child, this person has number, I mean, rating smaller than 4, so I have to do at least 1, 2. Then when I take a look at the 3, he has to get more candies than the right adjacent child, so it should be 2 and 1. And when this happens, I have to update this one. Yep, with the rating 4. So this is how it works, and I can see that all of them meets the requirement. Okay. So I think what I can say from here is that, yeah, so if the child with okay, if I decide the number of candies from the minimum number of, okay, so I will choose the number of candies to distribute from the child with lowest rating first. Then I will decide the children in ascending order of the rating. So in that way, what happens is that, okay, so I can say this is the 0 smallest, and I can say this is the second smallest, and this is also second smallest, this is third smallest. Yep. In the case of tie, I didn't consume index in this case. Yeah. In this way, what I can say is, for this person, I can choose it first, 1. Then for this person, I can choose it next, like 1. And then here, the number of, right child has lower ratings than him, so his candy must be higher, more than that person. So this should be 2. Yep. For the left person, it's not decided yet, but later we've decided. The good thing about this approach is that the child with the lower candy, which is standing next to someone, is already decided because I'm filling in the number of candidates in ascending order. Yeah. So in that way, yeah, I could choose this and this. Then I will think of this. So here I can choose a 2, which is 1 plus 1. Here, 1 plus 1, 2. And here, I will take a look at the right child rating 2 and the left child rating 2. So 2 plus 1 is 3. So this should be 3. If this is something like this, in that case, this will be 4 because I will take the minimum of 2 plus 1 and 3 plus 1. Okay. Good. So the good thing is that one more good thing, and one more thing I noticed, and also one more thing I have to take care of, how the order of filling in the order of, sorry, if there are many children standing in a row next to each other, which number should I decide first? Because that's what I have to take care. But I'm pretty sure I can choose. Yeah, the order doesn't matter in that case. For example, in this case, as I confirmed first, if the ratings are the same, if the rating of the adjacent child is the same, they don't have to take care of the number of candies each other. There's no, you know, comparison or yeah. I mean, number of candies for this and this can be any. 1 3 is okay, 3 1 is okay, 2 2 same is also okay. I don't have to take care the next child with the same number of rating. I mean, same rating, so I can choose in any order. Okay, so in this way, I can solve this question in n log n time because the first thing I did was, so okay, I will sort the array so that they are ordered in ascending order by their rating. And also I will keep track of the index for each child. And once it is sorted, I can choose the index, which is sorted by the rating in ascending order. Yeah. So once I get that, I will fill in the, array, which should be returned. Oh, no. I don't return the array, but anyway, I will create another, data structure like this. So this is the kind of extra array which I will use. So this should be O of n. Yep. Okay, so that's how it works. So that being said, I will start the implementation. I will quickly outline. So in this way, num is sorted in ascending. Right. Then initiate candies and yep. And I will return the sum of the number of candies instead. Okay. So okay, now I've finished the item number 1 in line 15. So I will do number 16. Fill in num candies placed in order. Okay. I've initiated the array and for each index, I will fill in the candies. So this is what I will do. So for that, as I said, I will take a look at the right, yeah, child and the left child. So I can do it in this way. So let me define n here. Okay, good. Oh, okay. So firstly, I initiate the count with 1 by default, which is the minimum number I have to distribute in any case. Yeah. And then in line 31, I will think if the left child exists and he has less candy than the current child, sorry, I have to take care of the ratings. Yeah. So if he has less ratings than the current child rating, in that case, the count is at least more than the child. I mean, left child. Okay. And in the case in line 33, in the case when there is a right child and his rating is lower than, I mean, less than the current child, in that case, the current child should have at least one more than the right child number. Can this count? Okay, looks good. So now we decided the candy. So okay, I did it. Good. Then so I've done the now I've done the line 16. So I do the line 17. Okay, good. So let me work through my code with a very easy example like this. But I'd like to take care of the case when, you know, um, the case of the tie. So I will do it in this way. Okay. So in this case, firstly, I will build the ratings with index array with 1 0 0 1 2 2 and 2 3. Okay. Then I will sort this array. So now this should be 0 1 should come here. Okay. So now in line 30, n is 4. Then in line 31, candies is initiated with non-array. Yeah. Then in line 35, I will, iterate this ratings with index array. And I will take a look at the second element in each tuple. So firstly, index 1. So I first reinitiate with count is equal to 1. Yep. Then in line 37, because index is 1, and the first, it has a left child, and ratings index minus 1, rating 0 is 1, which is larger than ratings index, which is 0. So I skip this and I go to line 39, and next index is 1, so it is smaller than 4 minus 2 is 2. So I will take a look at the right child, and ratings index is ratings 1, which is now 0. And ratings index plus 1 is rating index 0 plus 1, which is ratings 1, which is 0. Oh, sorry, wait a minute. No, index 1 plus 1. Sorry, so now I'm looking at index this 1. So ratings 2, index 2 is now 2, which is not smaller than 0. So I go to line 42, and I fill in candidates index with count, which is now 1. Okay, and when I come back to line 35, now I will take a look at index 0. And I will go quickly. So in line 7, this is not true, index because this is 0. So in line 39, index is smaller than n minus 2. This is true. And ratings index is larger than ratings index plus y plus 1. This is true because now it is 1 and 0. So in line 30, count is updated with candidates index plus 1, which is candidates 1, which is 1. So count is now 2. Okay. So I updated index 0 with 2. Okay, then next, I will take a look at index 2. So if index is 2 in line 37, index is larger than 1 through, and ratings index minus 1, and ratings index. So this should be index 0 and index 1. So it should be 0 versus 2. And index, the router is larger, so this is true. So now in line 38, count is max. Okay, so count is updated with candidates index 1 plus 1, which is now this becomes 2. Okay, good. And then line 39, index is smaller than or equal to n minus 2 is true, but ratings of index country 2 is not larger than ratings of index 3 because both of them are 2. So I don't update count here, and then go to line 42, and I fill in the candies index 2 with 2. Okay. Good. Wait, I forgot to update this. Okay. Now, in the end, I will take a look at index 3. So now count begins with 1, and then line 37. This is true. I mean, the first half is true because index 3 is larger than 1 or equal to 1. And then I will compare two ratings of index 2 and index 3. And I find that both of them are 2. So line 37 is not true. So I go to line 39. But here, now n minus 2 is 4 minus 2 is 2. And current index is 3. So 3 is not smaller than or equal to 2. So this is not true. I go to line 42, and the candidates of index 3 is filled in with count 1. Okay, so this, and then I return the sum of them, which should be 6. Great. So this is exactly what I expected. I'm pretty confident on my code, so let me execute. uh, indentation. Cannot unpack iterable non types. Sorry, this should be rating with indexes. And num candies. Oh, this with candies. Okay, I submitted my code. Good, accepted. Okay. So this is my first approach. I can solve this question with nlog and time complexity. But actually, there is another approach I can take to solve this question is the linear time over n. So let me think of it next. So when I get this, let me remember the process I took to decide the number of candies for each child. So I firstly, as I said, take a look at this. And firstly, I try to fill this with 1. Yeah. But I couldn't because there is an adjacent child on the left-hand side which has smaller than the number of candies. Yeah. And let me say, in this case, this so that's why I did have to distribute 2 candies to the first child, and I try to minimize the second, number of candidates to the second child, so I said with 1. However, when I take a look at this, again the same thing happens. So the child sitting next to him has lower rating, so this person has to have more candies than the right child. So I increment them like this, and then the same thing happens here, and this becomes 4, 3, 2, 1. Yep. Then here I can determine this until here because now the right child of this person has more candies. So I can say this child can have only one candy. That's enough. Then I will take a look at next and then try to start with 1. But then I find that this child has the right child which has lower rating. So I increment it like this. Okay. So what I can observe from here is that sorry, let me change this to say 2, 3 like this. In this case, I decided 1 here, and then what happens is I put 1 and 2 and 3. Yeah. Because, right child has higher scores than the current child, so left child has to have more candies. So one thing I've found from this is I can make an observation that if I take a look at the array in a reverse order from tail, and I find that the person, wait, I think what I can do is first 3 I will take a look as a child from, you know, head to tail order. Then I noticed that for this person, I cannot choose anything. Wait, I will just try to take care about this operator. I mean, um, less than, yeah. I will take care of only the less than operator, word traversal. So what happens is that I don't know what happens to be here. So I just put it 1, 1, 1, 1. But here, um, this person has higher, sorry, more greater than the greater rating than the previous child. So this should be 2 candies, 3 candies. And then, yeah, just in case, I will put some more example like this. So in that case, I can just put 1 and 1 here. Okay. Then next, what I will do is I traverse in a reversed order, and I will take care of only the. No, sorry, this is rest. Greater than operator only. So when I do this from here, I should put 1, then 2 and 3 here. Then here there should be 4. Then here, because I take care of only the greater operator, and 4 is smaller than the 5, I just put 1 here. And here I just put 1 here. Then I put 2, 3, 4. Okay. So now I have another candidates array, number of candidates array, which means the relationship of greater than operator. And then when I take a look at this and this, say if I have the max of them, let's see what happens if I take max. I'm not pretty sure it works or not, actually. So if I take max of them, here, this should be the first index should be 4, then 3, 2, 1, 2, and 4, 3, 2, 1. Yep. Okay, so I got this number of candidates array, and actually this meets the condition. Yes. But I'm not 100% sure this really works in any case. So let me, justify this. At least I can say about this block, 1 to 3 is the minimum relationships they should have. Yeah. And for this, in line 21, 4, 3, 2, 1, which appears twice, and for each of them, this is a kind of block I have to meet. Mhm. And one thing I can say is the block never intersect between these two candies array. Yep. So currently it looks like this. And what I mean to say is that it never intersects. So it never goes like this. Because if it goes like this, there's a contradiction. Yeah. Because here in this section, the first, result array, I mean, argues that left one is less than right one, but the second array argues that, the left one is greater than right one. So there's a contradiction. So they never intersect. Okay. So and that being said, I will decide the number of candies. So okay, I have to think of two cases, like this intersection here and this intersection here. So I can say yeah. In the first case, the kind of boundary point is a kind of valley. Yeah. And for the second kind of intersection, I don't want to say intersection, but yeah, boundary, it looks like the kind of mountain. And for the valley, yeah, this is easier to think because in this case, the number here should be always one. Both of them should be one because it's the valley. And there's nothing, no reason, no background that I have to put number more than one here. So it easily decided it was one, and I just have to follow. So in that way, this boundary is okay to be resolved with no update for each array. However, here, 3 and 4, if the I can see that 1 to 3 and 3, 4 to 3, 1. And I can say from 4 to 3 to 1, it has to be the number of candidates for this position should be 4 or more. And for the from 1 to 3, the number of candidates here should be 3 or more. I think the quick resolution is that it takes the minimum, and is that way, both of the, this block relation never breaks, and this, blocks relation never breaks. And I think taking minimum is the, best way to much, increasing. I mean, taking the minimum is the best way to make it minimum. I can do it while meeting both of these conditions. Okay, so that's my approach. So let me start the implementation. So I will quickly outline the solution. So firstly, what I will do is build this. So let me name it build like this. Then I build another array with considering greater than operators only, and then take mini max of them. Yeah. And I will return the sum of them. Okay. Actually, line 29 and 30, I can make it without building the new array. Yeah, but it definitely works. So the time complexity should be O of n, because line 27 takes O of n time, line 28 takes O of n time because I do the linear scan. And then line 29 and 30, I do another linear scan, so it should be O of n. For space complexity, the same. Because I build two, helper arrays, whose ranks, each of whose ranks is O of n. Okay, now let's start implementation. Okay, so this is it. So in line 38, I build the first helper array, and the same for in line 39. And then in line 42, I initiate the mini total count, which is updated in the for loop and eventually returned. Yep. And then in line 43, in the for loop, I will take a look at each position, and the number of candidates to put there is maximum of, the number of candidates at that position in each of candidates 1 and the candidates 2 array. Yep. Okay. Now I will implement build with only Western relations. So I can always start with 1. And I will take a look at the remaining, elements after that. So let's say I have something like, in this case, as I said, I start from here. Oh, so return of this this is return. Should always start with 1. Then I traverse the array, and if the current number is larger than the left number, I increment the count by 1. But if they're the same or smaller, I reset the count with 1. Okay. Like this. Okay, so now I will implement the second sub method. Yep. I actually use a small cheating here, a kind of cheating here. So when I reverse this given array ratings, let's see. So for example, in the case if I get like this, and what I try to get is something like this, obviously. Yep. And to get that, if I reverse this, it becomes like this. Then, as I calculate here, sorry, let me. When I reverse this, this should be like this. Wait a minute. And I guess the count. And what I will do is call build with only REST relationships. And when I do that, I get something like this. Yep. And then after getting this result, I get 1, 1, 2, 1. And this is obviously what I wanted to get from the original array. Yeah. So I can use this method. Okay. Let me do it. I don't want to, mutate the original array, so I initiate a new one. And I get the reverse ratings. No, reverse relay candies. And I reverse this. And I return this. Yeah. Let me just name it candies because I reverse it. Okay. So this is how it works. Okay. So I will skip the checks. Okay. So let me walk through my code. I will skip the checking for sub methods. Yeah. I will just focus on the logic of the main method. So when I get something like this, firstly, I will build the candies one array from the rest sum relationship. It becomes like this. Next, I will build the candies 2 from the greater than relationship. So this becomes like this. Then I will traverse from index 0 to index 3 in line 50, and minicount total becomes from 0 to, okay, from the first element I get 1, so plus 1. Then from the second element I get plus 1, no, plus 2, because I will take a look at max. Then from the third element I get plus 2. Then from the last element I get plus 1. So this should be now 6. The 6 is returned. And actually, the number of candidates I have should distribute actually is like this. Yeah, so I confirm that my logic is correct because expected number of candidates is 6. Okay. Now I'm pretty sure my code, so I submit. Typo. And type again. And I submit. Great, accepted. Okay, so I quickly wrap up my today's coding practice and finish. So in this video, I solved the question named Candy. And in this question, I'm given the array of ratings for each child, which is an integer array. Yeah, and I will decide how many candies I should distribute to each child with the requirement. Yeah. And my task is to return the minimum number of candies I have to prepare to distribute, to the children. And the requirement it was that if there is for two childs who are sitting next to each other, if one child has a higher rating than the other, then he has to get more candies than the other. And if, just in case the ratings of them are the same, so there isn't any requirement on the number of candies. Yeah. Okay, so that's the question. And I came up with two solutions. The first solution takes n log n time, and I used the sorting. Yeah, I sorted the children from lowest rating to highest rating, in ascending order. And I decide the number of candidates from the lowest rating child to the child with the highest rating. And this order of deciding candies worked quite well. Okay, and the second approach I came up with was kind of using the traversal twice in two parts and creates the kind of helper arrays, two helper arrays. And I decided the number of candidates for each child with these two sub-arrays. Okay, so it was my solutions. Okay, that being said, I finished my today's coding practice with this. Thank you so much. Bye.